This is a continuation of 3-2. We're on page 118. This time we're going to solve by using elimination. So elimination method, using this method, so we will eliminate one of the variables by adding or subtracting the equations. When you add two true equations, the result is an equation that is also true. Okay, what does this mean? So if we have two equations, the first one is 4a plus 2b equals 15. And the second equation is 2a plus 2b equals 7. Okay, so we want to get rid of one of these variables, just like in substitution. So we only have to deal with one variable so we can solve and figure out where our two lines intersect, which is our solution. Okay, so if we notice that the b term, 2b, in the first equation is the same in the second equation. It's also 2b. So if we subtract these two equations, we will see that the b's drop out. So what we do is we line them up. We have 4a plus 2b equals 15. Underneath that, we have 2a plus 2b equals 7. And so we subtract our like terms. We subtract our a's, and then we subtract our b's, and then we subtract the numbers on the right side of our equal sign. So let's look at our a's, our first terms of each of these equations. We have 4a minus 2a, and that gives us 2a. Now we have 2b, we have plus 2b in our first equation, and plus 2b in our second, but we're subtracting those. So we have 2b minus 2b, which gives us 0b, equals, we have 15 in our first equation, 7 in our second. So we have 15 minus 7, which gives us 8. So now our equation is 2a plus 0 equals 8. That 0 just drops out. So we have 2a equals 8. We can divide each side by 2 to solve for a. And we end up with a equals 4. Okay, so we now know that our a value is 4. So then we can put that 4 back into one of our equations. Either one will work, and that'll allow us to solve for b. So let's go ahead and see how that works. Let's do the first equation. Actually, we're going to do the second. We have 2a plus 2b equals 7. Now we're going to substitute this a value of 4 back into the equation. So we have 2 times 4 plus 2b equals 7. Simplify the 2 times 4, so we have 8 plus 2b equals 7. Now we subtract the 8 from each side. We get 2b equals 7 minus 8, or negative 1. Divide each side by 2 on the left. We have 2b. So on the left, we're left with just b equals negative 1/2. So now we have our a value and our b value. So we can say the solution is, open parentheses, 4 comma negative 1/2 close parentheses. And that is our ordered pair where these two equations intersect if we were to graph them. Okay, so that was nice and pretty. We had a variable that had the same coefficient. We had a 2 and a 2, so that was pretty. Now what happens if that's not the case? What if we have two equations that will not eliminate either variable just by adding or subtracting them? So we have to use multiplication to write an equivalent equation so that one of the variable has the same or opposite coefficient in both equations. Alright, so when we multiply an equation by a non-zero number, the new equation has the same set of solution. So what does this mean? Let's look at a couple of equations. So we have our system of equations at 3x minus 7y equals negative 14. Our second equation, which I write directly underneath the first one, 5x plus 2y equals 45. So our x values in the first and second equation, we have a 3x and a 5x. Those won't eliminate. Looking at our second variable, we have a minus 7y and a plus 2y. Again, neither one of those will eliminate just by adding or subtracting. So basically, we need to ask ourselves, okay, how can we multiply each equation to make one of the variables drop out? So we're going to make our y's drop out. So if we have a negative 7y in our first one, and we have a plus 2y in our second one, what do we need to multiply each equation by to make those opposite coefficients? The same number, opposite signs. Well, if we have 7 and 2, the lowest common number they both go into is 14. So in our first equation, we say, okay, we have negative 7. Now we need to multiply that entire equation by 2, and that'll give us a 14 in our y term. So let's do that. So if we multiply our first equation by 2, the whole thing, each term distribute a 2 through. So we have 2 times 3x, that gives us 6x. 2 times minus 7y is minus 14y equals 2 times negative 14, or negative 28. And it's really important to remember, if you multiply the left side of the equation, you have to do the same thing to the right. Okay, second equation is 5x plus 2y equals 45. And we want that y value to be 14. So 2 times 7 is 14. So we multiply the whole thing by 7. So let's do that. I'm lining this up right underneath the first equation. So 7 times 5x is 35x. 7 times plus 2y gives us plus 14y equals 7 times 45, which is 315. That comes after the equal sign. Okay, so now we just need to add these equations. And the reason we're adding these and not subtracting them is because we have opposite signs on our y terms that will drop out. So we don't want the sign to change. So if we have 6x plus 35x, that's the first term in each of our equations, we get 41x. Now we have 14y, negative 14y plus 14y, our y's drop out because that's 0. And now we have negative 28 plus 315, which would give us 287 to the right of the equal sign. Okay, so we have 41x equals 287. Go ahead and solve for this. Divide each side by 41. And we have 41x divided by x gives us x equals 287 divided by 41 gives us 7. So our x value is 7. Great, we know one of them. So we then go dump that back into one of the original equations before we multiplied it by a 2 or 7 and solve for our y because our x value is 7. So we're going to put it into the first equation, which is 3x minus 7y equals negative 14. So that is going into that equation. So we have 3 times 7 minus 7y equals negative 14. 3 times 7 is 21 minus 7y equals negative 14. Add that 20 or subtract that 21 from each side, we get negative 7y equals negative 14 minus 21, or minus 35, negative 35. Divide each side by negative 7, we get y equals a positive 5. Okay, so now we have a y value of 5. So the solution is open paren 7, comma 5, close paren, and that is the intersection or the solution to our problem. Okay, so now we have something called an inconsistent system. So sometimes we have two equations that are never true. If we have two lines that never intersect, like parallel lines, we're never going to have an answer where they intersect. So what does this look like when we're using the elimination method? So if we have two equations, the first one being 8x plus 2y equals 17, and we have negative 4x minus y equals 9. And we want to use the elimination method and solve for this. So we can eliminate one of the variables. Let's pick one. We're going to look at the eliminating the x. We have an 8x in our first equation, and we have a negative 4x in the second one. So what would we need to multiply an equation by so that it drops out? Well, if we already have 8x in our first equation, and our second one is negative 4x, if we multiply the second equation by 2, that does allow us to eliminate that x variable. So let's go ahead and do that. If we multiply everything by 2, what we end up with is negative 8x minus 2y equals 18. Now our first equation was 8x plus 2y equals 17. So let's go ahead and add these because we want those 8x minus 8x to drop out. So 8x minus 8x is 0. Now if we look at our second one, we have a positive 2y plus a negative 2y. That also equals 0. So now we have 0 plus 0 equals 17 plus 18, which would give us 35. So what we have now is 0 equals 35 because everything on the left side dropped out. And that is not a true statement. 0 is not equal to 35. So that means that this system of equation is inconsistent, that there is no intersection, there is no solution to this problem. So this is an inconsistent system or a no solution.